Now, before we start, I just want to make it clear, I don't claim to be an expert on this topic. I'm not a scientist in this field, and much of the information that I've actually derived or placed here today is really from the work of a very talented researcher. Her name is Susan Owens. She's been working on this topic, the topic of oxalates, for a very, very long time. And she's got some information over on a website called Low Oxalate Info, and she runs a Facebook group called Trying Low Oxalates. So I just want to make it clear that this is not my research. It's really, I credit Susan Owens for this. But ultimately, I feel that if we can get it out to the public, if people can learn more about it, then hopefully things will become more clear. So what we're going to be talking about really is we're going to be going into the basics. First of all, people might have heard of oxalate. They might have heard that it can be problematic in their diet, but they don't necessarily know what it is. So I just want to cover the basics of what it is, where you find it, and then we're going to go into some of the details, and it might be a bit technical in some places, but we'll try to keep it simple and explain the topic. Okay, so to start off with, when we're talking about oxalate, oxalate is contained in many foods, but basically when you break down the chemical structure of oxalate, it's actually made up of oxalic acid. So oxalic acid is an organic acid. Okay, you find it in nature, and it's ubiquitous throughout the plant kingdom. It's in lots of different plants, some more than others. Okay, it's generally very low in animal foods, and it's also produced by the human body. So your body does make oxalate. Okay, the problem is that in normal human metabolism, it's meant to be in very low amounts. Okay, so oxalic acid, you can think of it a bit like a magnet. Okay, it's a magnet in that it has a very high affinity for various minerals. Okay, so it comes along and it binds with those minerals very tightly. Okay, so there we've got the diagram of the magnet there. So oxalic acid, when you have oxalic acid, it binds with the mineral, and after it's bound, it forms something called an oxalate salt. And that's what we're referring to when we're talking about oxalate. Okay, so oxalate is generally not referring just to the oxalic acid, but it's actually referring to it being bound with a mineral. Okay, so it has affinities for various minerals. It can form what we call a soluble oxalate salt, which means that it can travel in the blood. Okay, it's water soluble, but it can also form an insoluble oxalate, and that's calcium, mainly calcium. When it binds with calcium, it basically forms like a crystal. Okay, and this can't travel through the blood. Okay, this can't be absorbed into the gut, and the reason I'm saying this, it's a point that really needs to be emphasized. When oxalic acid binds with calcium and it forms that insoluble salt, this is where it can really cause problems for the human body, and we're going to be looking at exactly how this can occur. Okay, so when we look at the structure of the oxalate crystal, after when you've got the oxalic acid, when it binds with calcium, it can basically form various different kinds of crystal structures. Okay, so you've got the image here, and it shows these are called raphides. Okay, so you have like spiky fork-like needles kind of thing. You also have various other shapes and sizes. You can have like rectangular or diamond-shaped crystals. And this is important because these are physical structures. So essentially, when this comes into contact with a tissue, it's a bit like a razor blade. You can imagine if you held a razor blade to your arm and you sliced it, it would cut through your arm. And it's very, very much a similar concept, whereby the physical properties of the oxalate crystals are actually severely damaging to physical tissue. And it's because of this structure, because of these qualities, researchers have long proposed that oxalate is actually an inbuilt defense mechanism by plants. So plants which have very high levels of oxalate, if you think of it like this, plants want to survive just like human beings do. Okay. And the way that they do that, they can't run away with their legs. They can't fight you off. They can't bite you. But what they can do is they can operate on a biochemical or sort of physical level to deter herbivores from eating them, to deter other animals. And this is like a survival strategy. And so because of these structural or the structural qualities, because it's so spiky, basically, this is not an attractive prospect for an animal who's going to eat it. Okay. And so if we look at the next slide, you can see on the images there, oh, sorry, I just need to go back there. Right. So yeah, you can see this is what it looks like when you take a microscope to it and you really look at it on the on a close-up level. You can see it's very abrasive. Like, sorry, need to get a hang of this. Right. So as I said, not all plants are created equal. So you have oxalate found in many different plants, but some of them have negligible amounts. On the other hand, many of the so-called health foods or superfoods, which most nutritionists or naturopaths recommend as part of a healthy diet, are actually extraordinarily high in oxalate. And this is something that I'm going to try to emphasize throughout, is that people who follow ketogenic diets need to be aware of this, because many of the foods on a ketogenic diet, which are recommended to be eaten liberally, things like spinach, kale. In the paleo community, you have sweet potato and beetroot. I mean, these things are eaten in excess. But you also have nuts. Almonds are extraordinarily high in the legumes, like peanuts. There's a list here of the foods which really have the highest amount, but you'd be quite surprised, because really there are many other plant foods which contain seriously high levels of these oxalate crystals. Okay. And so if we're looking at how the body is going to basically absorb oxalate, so when you eat foods which contain high levels of oxalate, in plants, just to give an overview, in plants you have free oxalic acid, you have soluble oxalate, and you also have insoluble oxalate. So the soluble forms, like if you have potassium or sodium oxalate, or you have free oxalic acid in spinach, what will happen is that you will absorb that in the intestine. Okay, it will go into the blood and it will go straight to the kidneys. And when it goes to the kidneys, ideally it's going to be excreted through the urine. So the main way that the body actually gets rid of this oxalate, because oxalate is a poison, okay, it's a toxin, your body cannot do anything with it, your body just needs to get rid of it. So it's going to go through the urine. And it's no coincidence that one of the main areas of research in terms of oxalate research is actually on kidney stones and renal failure, because oxalate because its main route of excretion is via the urine, it can have a seriously detrimental effect on kidney function. Okay, now not all oxalate is absorbed. Okay, some of the oxalate, what we refer to as insoluble oxalate, is actually bound with calcium. So that calcium might be in the food, or it might be with other food that you're consuming. So I'll give you a hypothetical. If you eat spinach in conjunction with cream cheese or in conjunction with some dairy, there's a good chance that you're going to reduce the amount of oxalate that your body absorbs significantly. Okay, and this is because oxalate's affinity for calcium is higher than for any other mineral. So calcium in that sense is highly protective against the damaging effects of oxalates in foods. To switch that up on its head, though, is that it's going to reduce the bioavailability of the calcium as well. So, for instance, if someone tells you that spinach is really high in calcium, you can almost guarantee that most of that calcium is going to be bound up with oxalate, and you're not going to absorb it, okay? Because it's insoluble, it cannot get through the intestine and into the bloodstream. So you're not going to absorb that. You're actually going to excrete it through the feces, okay? So ideally, in a normal scenario, the human body will sort of cooperate with the gut bacteria. And if the diet is sufficient in calcium, then the amount of oxalate that your body absorbs is going to be almost regulated. Okay, it's not going to be excessive. It's going to be limited somewhat. And there's various things that can affect how much the body actually absorbs. Okay, so for instance, in the gut, you have a certain type of bacteria. Bacteria. Okay, and what they do is they take the dietary oxalate and they basically metabolize it. They get rid of it for you. So these are really protective. The most well-known of these is actually called Oxalobacter, but also many of the other commensal flora, such as the Lactobacillus or the, I believe, Bifidobacteria. These also have the ability to break that down. Now, one of the very interesting things is that specifically if we're looking at Oxalobacter, there are many antibiotics which actually can be very detrimental for these oxalate degrading bacteria. Some of the most well-known ones, one of them is the fluoroquinolone antibiotics, such as ciprofloxacin or levofloxacin, but there's also many others such as nitrofurantoin, I believe maybe tetracycline, but I'm not entirely sure about that one. But there's basically, what you need to know is that many antibiotics, if you've taken antibiotics, what it can essentially do is kill off the bacteria that is protecting you against dietary oxalates. And so this is one of the main risk factors into like a gut dysbiosis, is basically if you have had many rounds of antibiotics in your lifetime, you've essentially killed off these beneficial gut microbes, then you are potentially going to be one of the people who is absorbing a ton more oxalate than the average person. Okay. Likewise, if you've got any kind of small intestinal bacterial overgrowth or anything which is hampering your ability to digest fats, so this could be poor bile flow from the liver, this could be pancreatic insufficiency, anything which inhibits your ability to basically emulsify fatty acids, what this is going to cause is fat is going to get into the intestine. It's going to free fatty acids, which are unemulsified, are going to basically exist in the intestine. And what these do is they bind up the dietary calcium, leaving less calcium to bind with the oxalate, leaving more oxalate to get into the bloodstream. Does that make sense? Okay.
Yeah.
So finally, one of the other factors is leaky gut or intestinal permeability. So basically, the intestine, the tight junctions, which basically determine what goes in and out of the bloodstream, when this is damaged or when this mechanism is reduced for whatever reason, then this has also been shown to increase oxalate absorption. All right. So any of those factors is going to mean that someone is much more likely to absorb more oxalate. And so when we're talking about high oxalates in the body, before we go into the mechanisms of exactly how this causes problems for the human body, there are actual medical terminology referring to the body having too much oxalate. And so you have two different types. You have primary hyperoxaluria, and that means that someone is genetically predisposed. They can have certain polymorphisms or certain mutations in genes involved in the body's own processing of oxalate, the body's own ability to process various metabolites. And this basically means that they are producing way too much oxalate in their liver. And this is referred to as the primary form, whereas we have another form, and this is environmentally or diet induced. And so this is secondary hyperoxaluria or enteric hyperoxaluria. What this basically means is that someone's diet, someone's lifestyle, or various other factors are basically causing them to absorb way too much oxalate in the gut, and this is causing stress on the rest of the system. So for instance, if there is gut dysfunction, if you have someone with celiac disease, leaky gut, as I've said, this markedly increases the amount of oxalate absorbed. Likewise, there are precursors in the metabolic pathways whereby the body actually produces its own oxalate. This could be glycine, excessive intake of glycine, vitamin C, and hydroxyproline, which is an amino acid. These can also go on to produce too many oxalates in the body. But finally, and this is the point that I really want to stress, is that a high oxalate diet is a major risk factor for having too many oxalates in the body. Now, there's people in like the plant-based community who basically say that the cause of oxalate problems in the body is gut dysbiosis, or it's some other kind of dysfunction which is causing the oxalate problems, and that ordinarily high oxalate diets can be healthy. Whereas I would come from I would counter that, and actually I'm going to cite research showing that a high oxalate diet can independently cause oxalate problems. And so when we look at many of the paleo diet, the ketogenic diet, but even vegan and vegetarian diets, these are very high in sort of almost tropical foods, which us in the northern hemisphere anyway don't have access to at any time of the year, never mind in the winter time. And so what we're potentially doing is we're feeding our body with all of these oxalates, and I think this is causing problems. So these factors basically cause too many oxalate in the blood. When oxalate circulates through the blood, as I said before, most of the research has actually focused on kidney stones. So if you type in oxalate into PubMed, you'll see that the majority of research articles are actually on kidney stones, on nephropathy, on renal failure. And so this is because essentially when oxalate is high in the blood, it goes to the kidneys, and it can basically bind with calcium, because you have lots of minerals in your blood, you have lots of minerals in the fluid in your body, and so it binds with the calcium, and it can actually basically lodge in the tissue of the kidney. And so this is, if you look at kidney stones, roughly 80% of them are calcium oxalate, and this is due to this mechanism. But ultimately, this is not just related to the kidneys. And I think this is where many researchers have actually gone wrong, is that assuming that it's just a kidney problem. When we look at the effect of oxalate on the human body, it is actually being implicated in many, many different conditions. Now, we're talking about oxalate related arthritis, glaucoma, inflammatory bowel disease, cystic fibrosis, autism, interstitial cystitis, vulvodynia. I mean, there are many different health conditions where oxalate can actually be a driving factor. Okay, and we're going to go into how this might actually occur. But there are certain symptoms which seem to be more commonly related to oxalate problems, and sometimes people may not necessarily relate this to their diet, but some of the really common ones, I mean, first of all, joint pain. Joint pain is such a common, joint and muscular pain is a really common issue with people with oxalate problems. And this is actually because the oxalate crystals, if you think back to the structure, what we were talking about before with the spikes and the weird rectangular sort of spiky formations, these can actually deposit in the joints. Okay, when they deposit in the joints, you imagine you've got like a razor blade, a very tiny razor blade deposited in a tissue in your joint. Every time you move that joint, that's going to cause pain. Okay, that's going to cause inflammation. So this is very common, but you also have other things. I mean, itchy eyes, because oxalate can come out of the eyes, it can come out of the skin, it can come out of the urine. So I've got a couple of clients at the moment who we have established that they have oxalate problems, and their main complaint is actually chronic bladder irritation. So some of them have microscopic blood in the urine, but there's no sign of urinary tract infections. And so the doctors or the GPs had no idea what is causing this. But ultimately, as I said, after oxalate is excreted through the kidneys, it goes into the bladder. And when it gets into the bladder, these crystals can actually lodge in the lining of the bladder, in the tissue of the bladder, and throughout of the urinary tract. And so you imagine, as I said, like a razor blade taking small cuts into the bladder, you're going to cause inflammation and irritation and all of these things. Okay, so now we're just going to go into the mechanisms of how oxalate really can be problematic for so many people. So as I just said, it can deposit in a tissue as a calcium oxalate crystal, and this is, you can think of the problems related to this as purely mechanical, really. Very mechanical shredding action against the tissue, cutting away, causing irritation. And as I said before, it's not only related to the kidneys and the urinary tract, but actually when you've got high circulating oxalate in the blood, you're going to potentially be getting oxalate crystals which are being deposited in practically any organ you can think about. So I've listed some of them there, and it's quite amazing because if you look at the clinical research, these are some of the places where oxalate crystals have been found to deposited. The thyroid gland is really quite common, and when it gets to the thyroid gland, it can completely disrupt thyroid physiology. You're talking potentially driving autoimmunity and things like that. But in the bone, in the skin, in the liver, in the brain, and I mean, you can see the image here of the crystal. This is not something that you would want to be deposited in the organs. Okay, this is really not something that is going to cause. Basically, it's going to cause problems. All right. And so, aside from the mechanical effects of oxalate, as I said, oxalate can really have a mechanical shredding effect, but ultimately it also operates on a biochemical level as well. So you have extra large oxalate crystals, but at the same time, you also have these things called micron and nano-sized crystals. So these are like extremely small shards of oxalate. And because they're so small, they can basically pass directly through the cell membrane. And what that means is they get into the cell. And when they get into the cell, they have various different effects. So they inhibit certain enzymes which are involved in your body's ability to take fuel, such as carbohydrate, such as fats, and such as proteins, and convert them into energy. Okay, so there's a step it's referred to as glycolysis. It's the first step of how we break down carbohydrates. And there's an enzyme called pyruvate kinase, and that's a key step in glycolysis. But this is inhibited by oxalate. Again, oxalate can also sort of insert itself into other enzymes, which are called carboxylase enzymes. These are basically dependent on one of the B vitamins called biotin. And what oxalate does is it essentially inserts itself into the place of biotin and stops those enzymes from working as well. Now, without going into the biochemistry, all of these enzymes are really critical for maintaining energy balance, for maintaining metabolic flexibility, the ability to shift from fat-based metabolism to carbohydrate-based metabolism. And so the ability to make energy from food really depends on all of these enzymes working together and operating in a functional way as they should do. Okay. Now, when it gets into the cell, I've titled this Intracellular Destruction. I don't think there's any other way to put it. Oxalate is a poison. Oxalate is a serious toxin. Okay. When it gets inside the cell, it interferes or it disrupts practically every known function, like all of the organelles. So the little pieces of machinery inside the cell which are used to perform various functions, and all kind of work together as a whole to keep a healthy cell. Oxalate seems to interfere with, almost every step of that process. So you have cell death. Oxalate can independently cause cells to swell up and burst. It actually causes the cell membrane to rupture and the fluid inside the cell to actually leak out of the cell and or come into the cell and actually cause the cell to swell up and, as I said, burst apart. But at the same time, there's also another mechanism by which it kills cells. It causes them to shrink and basically crumble away. You have you have these organelles called lysosomes, and lysosomes are essentially the piece of machinery in the cell which you use to degrade old components and things that you don't need anymore. Unfortunately, what oxalate does is, because it's sharp, because it's spiky, it can basically break apart or pierce the lysosome, causing the lysosome to leak out these really destructive enzymes called hydrolytic enzymes, as you can see here on the diagram. And when you have hydrolytic enzymes leaking out, these actually start to digest and degrade healthy components of the cell as well. And that's generally not something that you want to happen. So the point that I'm trying to get across is that oxalate is not only a mechanical problem, but it operates on a biochemical level, and it can essentially disrupt every single aspect of cellular physiology. Okay. Now, many of your listeners, Bart, I'm sure they know a lot about the mitochondria, but for those who don't know, the mitochondria is essentially the cell's energy factory. All right, it's where the magic happens. It's where we produce the final product, ATP. It's how we produce intracellular water. It's really center stage in many chronic illnesses. And there's researchers who are basically positing that mitochondrial dysfunction may actually be at the root of the majority of modern illnesses today. And so maintaining healthy mitochondrial function is, a critical aspect of maintaining health. And so, again, probably not to anyone's surprise by now, oxalate can independently cause mitochondrial dysfunction. So you have mitochondrial antioxidants such as superoxide dismutase. You have glutathione. The stress caused by oxalate actually depletes those critical antioxidants which are needed to keep the mitochondria healthy. But you also have a disruption of the mitochondrial membrane potential. And so this basically causes changes in the amount of ATP that you're able to produce, and essentially screws with the way that the mitochondria works. So this is, something definitely concerning. And again, finally, what it does, when it's deposited into tissue, without going into the mechanism, it triggers something called the inflammasome. And the inflammasome is basically a multi-component piece of machinery inside the cell which regulates immune responses, regulates the body's ability to sort of coordinate inflammatory responses, how it deals with inflammation and dysfunction. And so the inflammasome is essentially implicated. It's been implicated in chronic inflammation, autoimmune conditions, cancer. I mean, practically any modern illness that you can think of, activation of the inflammasome has been implicated in that. And we know that oxalate can actually do that independently. So there are people who will try to tell you that gut dysbiosis is the main cause of oxalate problems. And while that may be the case for some people,
carry on.
Oh, carry on. Right. Okay.
Yeah. I was just pointing out who it is that says that. It's that guy that says roll the credits and send me your shit.
Oh, okay. Right.
Sorry, yeah. Alec, carry on.
No, it's fine. Yeah. So whilst this may be the case for certain individuals, as I said before, we're talking about antibiotic use, people depleting certain gut bacteria. That can potentially cause someone's problems with oxalate. But at the same time, there is also some research to suggest that a high oxalate diet, or when you expose oxalate degrading bacteria in the gut to excess oxalate, what it actually does is it has the opposite effect. So it inhibits those bacteria. It kills off those bacteria. Okay, this research study is very interesting results because it showed that, okay, oxalate degrading bacteria can only deal with so much. There is a limit. And ultimately, when you pass that limit, when you give them too many, such as if you're drinking green smoothies on a daily basis, or you're eating almond flour cakes on a daily basis, what you are potentially going to do is cause dysbiosis. You're going to overwhelm those protective gut bacteria. And again, this is probably going to lead to absorbing more oxalate. All right. Again, there are people who will say that candida is a cause for oxalate problems. There is, in the functional medicine world, there is the notion that candida can produce its own oxalate. Now, I personally have not found any convincing evidence of that. I think it's a hypothesis. But, Susan Owens has spoke about this in the past and kind of highlighted that there is not really any data to prove this notion. And in fact, it turns out that oxalate is not only toxic to human beings, it's not only toxic in high levels to oxalate degrading bacteria, it's also toxic to candida. Okay, so candida need to metabolize energy just like human beings do. Candida cells take substrate and they convert it into usable energy to basically maintain their daily function. What oxalate does to candida is it blocks candida's ability to make energy. Okay, and when this happens, it turns candida from being a healthy, like a commensal yeast, because everyone's got candida in the gut. Candida is not the problem. It turns it from this healthy state to actually to a hyphal state, to a one that produces biofilm, one which is actually pathogenic, which, if you know anything about candidiasis, this is a pathogenic form of candida. And so it has multiple different states. And so candida is simply responding to the environmental cues. When you feed candida with too many oxalates, you're potentially going to cause yeast problems. You're going to cause candida overgrowth in your gut. There's it's no longer going to be a healthy form. It's potentially going to be a pathogen. And so many people, I just want to highlight here that many people, if they think they've got candida, they might take antifungals. Okay. But if candida is merely responding, is operating via a protective shift and is simply responding to a high oxalate diet, then what is an antifungal going to do? Because you're not getting to the root of the problem. It's simply killing off the fungus. The fungus is a symptom, not the cause of the problem. Now, I'm not saying this is the case in everyone, but there are I tell you what, there are hundreds, if not thousands, of anecdotal accounts of people who have had chronic yeast infections, chronic problems with kind of candida, and they find that when they start reducing oxalate in the diet, that the yeast issues naturally go away in and of themselves. Okay, so I suspect that the the it's really quite common to have yeast issues in our modern world. I really suspect that a lot of this is coming from oxalate in the diet. I really do. And now, finally, really, this is what actually really piqued my interest to research oxalate, is because I was learning about sulfur chemistry and sulfate and how the body actually processes sulfate. Bart, I'm not sure if you're familiar with the work of Dr. Stephanie Seneff.
No.
Okay, right. So Dr. Stephanie Seneff, just to briefly detour, Dr. Stephanie Seneff has done a lot of work on sulfate and on glyphosate, and the way that glyphosate, she's most well known for her work on glyphosate, but really a lot of this is actually stemming from how this disrupts sulfate in the body. And so you see sulfate, if we're looking at things like detoxification, if we're looking at things like producing structural elements such as macromolecules, proteoglycans, sulfate is extremely important for these things. However, Dr. Stephanie Seneff's work has really shone light on how sulfate in the body actually really exerts biophysical effects in terms of allowing the body to actually produce structured water. So the work of Dr. Gerald Pollack and many other water scientists in recent decades has basically shown that water can exist in multiple different states, in a fourth phase. And this is like a gel, like a battery. It can act like a battery for sunlight, and that it probably plays a very large role in human physiology and how things work. And so what she's shown is that sulfate is actually one of the critical elements in producing structured water and producing this gel-like battery, and that when the body is low on sulfate, it's theoretically possible that the body can no longer effectively structure water inside and outside of the cells. Okay, and so the reason I'm saying this is because oxalate actually has a very interesting relationship with sulfate. There is what you call certain transporters on the cell membranes, and these actually have they facilitate a bidirectional exchange of sulfate ions and oxalate ions. So just to keep this simple, basically when there is high levels of oxalate on the one side and lower levels of sulfate on the other side, what you're going to do is you're going to basically, for every oxalate that goes into the cell, then a sulfate is going to go out of the cell. And so if you've got very high levels of oxalate traveling in circulation, what you're doing is theoretically what you're doing is you're pulling out sulfate. And this can Dr. Rostenberg, he wrote a very comprehensive article on this, but he also made quite a good video on it as well. He's basically explaining how this can work. But what you need to know is that sulfate is bloody important for many different things, and that high levels of oxalate in the diet can essentially cause sulfur wasting. It can competitively inhibit the uptake of sulfate into cells, and can potentially screw with our body's ability to really to metabolize sulfur. Okay, so this is a really key point. And just to add to that, people with oxalate problems also usually have histamine and salicylate sensitivity. So problems metabolizing these various plant compounds, or when meat is, left to cook for too long, it's left overnight, our ability to metabolize the histamine in that can basically be screwed by oxalate. And again, anecdotal reports suggest that people who reduce oxalate in the diet generally tend to see benefits on multiple different fronts in terms of their biochemistry. So again, I'm coming back to the ketogenic diet, and I believe this is actually, I would say, I think this is one of the main problems with the ketogenic diet as it's practiced today. So many people, they might go on a ketogenic diet and feel benefits, but then after a year, after maybe 18 months or 2 years, they start coming up against major stumbling blocks in terms of their health. They might actually get really sick. And I think that people, what they're doing is they're attributing this to a ketogenic diet. But I don't believe this to be the case. I think one of the reasons is if you pick up any ketogenic cookbook, you're going to see foods or ingredients which are extraordinarily high in oxalate. So here's just some of the examples. Almonds, nuts, seeds. The keto advocates will tell people that they should be eating lots of, nut flours as a substitute for grains, because that's what we do in paleo. We take grains and then we substitute them with other things, which is kind of bizarre, really. If you see the amount of almonds that you need to make a bag of almond flour, you'd be amazed. But again, the point I'm trying to make is many of the staple foods on a ketogenic diet are in fact just so high in oxalate, and these foods are usually grown seasonally as well. And what we've done is we've lost that seasonal aspect to our diet, to the way that we're eating. And again, I don't think that the human body is designed to have access to these foods in such high quantities all year round. Okay, I don't think that that is compatible with human physiology. And so I've said here almond flour muffins and green smoothies. Well, again, these sound like what someone would have on a vegan or a superfood diet, but ultimately you'd be surprised at how many people on paleo or on a keto diet actually have green smoothies and are cooking with almond flour every day. Now, I did a rough calculation, and I can't guarantee that it is exact, but the average daily intake of oxalate in the American diet, I believe, is roughly 150 milligrams. That's per day. Okay. Now, if you look at the at the ingredients list to make a paleo cake, it might ask for 2 cups of almond flour. Okay. And per 1 cup of almond flour, you're potentially getting 220 milligrams. So you're already surpassing the daily intake of oxalates. Okay, that's just from 1 cup of almond flour. Now, if you look at a green smoothie, if someone is juicing like a green smoothie with spinach, with kale, with berries, with cacao powder, with all of these things, you're potentially one smoothie. Okay, so you're looking at about 5 times the daily recommended allowance or the daily intake in one drink. Okay, now this is a new fad. This is a new thing. Human beings, from what I understand, were not making green smoothies just 100 years ago. This is very new, and I don't think human beings benefit from this kind of dietary protocol because it can cause so many bloody problems with oxalates. Okay, now just to briefly detour, I mentioned before that the body can produce its own oxalate. Okay, now ordinarily this doesn't happen in very high amounts. It's a very minor pathway, and the body can essentially deal with that really quite well. It happens in the liver, and oxalate is like the metabolic byproduct of glycine. So the amino acid glycine, the amino acid hydroxyproline. Also, if there's excess vitamin C, vitamin C can spontaneously oxidize into oxalate. And there are various other precursors. As I said, this is a minor pathway. However, now I haven't gone into the metabolic pathway. I haven't gone into the biochemistry. I do that on my channel on YouTube, and I've also done that on my website in an article that I wrote about it. But essentially what you need to know as the listener is that the amount that your body can can produce actually increases drastically under certain conditions. So healthy conditions, you don't produce a lot, but under certain conditions, and these are vitamin B6 deficiency, okay, thiamine deficiency, and oxidative stress. So when any of these three criteria are met, what the liver basically has no other option but to start producing a bunch of oxalate. Okay, and this again can be independent of a high oxalate diet. So someone may not have a high oxalate diet, they may be B6 deficient, they may be thiamine deficient, or maybe they've got some kind of underlying chronic toxicity, such as metals, such as pesticides, these kinds of things, which are causing oxidative stress. Oxalates may still be a problem. Okay, and under these conditions, and this is something that I wasn't very pleased to hear, is that glycine, so glycine supplementation, if you look at the clinical research for glycine supplementation, it's really quite good, you know, especially for people who are on quite a suboptimal diet. Taking glycine in the form of a supplement or in terms of collagen powder can actually be, you know, very beneficial for various things. However, if someone has this problem, so B6 or thiamine deficiency, if they have this problem of producing too many oxalates in the body, then taking glycine actually can increase that. It can actually contribute toward the problem. So for these people, glycine supplementation is probably not a good idea. Okay. Now, again, the topic of your channel, Bart, and really the main point that I want to get across here is really why animal-based diets are going to be optimal for anyone who has oxalate problems or anyone who wants to prevent having oxalate problems. Benefits of an animal-based diet, if we're looking in terms of oxalate metabolism, well, there's various inflammatory components. We've spoken about oxalate, but there's also loads of other inflammatory components contained within plants, especially if someone has poor gut health. So when you go on an animal-based diet, you're improving digestion, but what you're also doing is you're reducing the overall load of the fiber, of all of this other kind of stuff that can cause problems. Okay. An animal-based diet is very likely to be thiamine sparing. Okay, because you're not using carbohydrates as your primary fuel. You're not going to be using the enzyme. It's called pyruvate dehydrogenase. You're not going to be relying on that pathway as much. Okay, so essentially it's theoretically possible that you may be using significantly less thiamine. And I think that Dr. Sean Baker has spoken about this in the past, and maybe some other doctors in the carnivore community. If you just look at the biochemistry, you're using much less. And so it would make sense as to why this might benefit someone if they do have oxalate problems. And again, it's extraordinarily rich in vitamin B6 in the bioavailable form. So you can get B6 from many plant foods, but are you able to convert that into its active form or not? Well, the form of B6, no, the likelihood is probably not, especially if you're depleted in, you know, a bunch of other nutrients. So if you're getting B6 from an animal foods, generally it's in a much more bioavailable and usable form. And finally, animal-based diets are the ultimate low oxalate diet. Okay, so there's low oxalate diets, there's many low oxalate diets, and people will basically reduce things like spinach, rhubarb, all the high oxalate foods, but they'll still contain plant foods. As I said, plants, pretty much all plants contain some level of oxalate. When you go on an animal-based diet, this is really the ultimate low oxalate diet, and I think this is why many people do see so many benefits in terms of joint pain and whatnot. I would imagine that some of the miracles that we see in the carnivore community, in terms of people like reducing their pain by 90% within a week or two, I would suspect that at least some of those people are actually suffering from oxalate related problems, and that by getting rid of those in the diet, you're actually really helping the body to process that along. So just to sort of round this up, to give the listeners some understanding of how the body gets rid of these things. So there's a phenomena referred to as oxalate dumping. Okay, and many of you may have already experienced this if you are on a low carbohydrate diet, if you are on a carnivore diet. But essentially what this means is that when the body, when the dietary load of oxalate is reduced, when you start lowering oxalate in the diet, say someone goes on a purely carnivorous diet, you're going to go from a very high intake to a very low intake. And what that does is it kind of sends a message to the body that it's okay to start getting rid of this stuff now. It can deal with the burden. There's not as much coming in, so it doesn't have to worry about that. So it can start actually doing what it can to get rid of it. And so this excretion process is called dumping, and it happens in like a cyclical fashion. So it's usually every 2 to 3 weeks, people go through dumping phases. So they might have an exacerbation of symptoms every 3 weeks. For instance, someone may have UTI related or kind of bladder irritation or joint pain every 3 weeks, or skin rashes or itchy eyes or something like that, because the oxalate is potentially going to be coming out from every orifice of the body. Okay, the body will just get rid of it in any way. And so you have an exacerbation of symptoms. This can be any kind of symptom. And I said the common symptoms before, but really if you look at how oxalate affects both outside of the cell and inside of the cell, then you see that oxalate can really potentially contribute to any problem that you can think of, really. It can disrupt many different things. So ultimately, it's highly individual and it differs from person to person. Okay, now for those who are a bit more technically minded, testing can actually be done. There is only one lab that I know of that tests all three metabolites, and this is using the organic acid test. And it can basically, you see the markers, it measures glycolic acid. So when these are elevated, these two are elevated, this actually indicates endogenous synthesis. So that could be due to B6 or B1 deficiency. But at the same time, you also have oxalic acid, and this is generally reflective of dietary oxalate. And the body is excreting of that. And so ultimately, if people did want to test for that, there is a lab. It's Great Plains Laboratory who do that. Okay. Now, finally, I just want to say that if someone, in the oxalate community, it's generally not advised for people to jump into this too quickly, because it can kind of cause a massive flare-up of symptoms. And in some individuals, I believe they have actually been put into A&E because they've gone into like a health crisis because their body starts dumping so many oxalates really quick. So the general recommendation is that people reduce it by around sort of a tenth. So you add up what's in your diet and then you divide that by 10, and then you reduce it by a tenth each week until you get to the 10th week where you're on like below 50 milligrams per day. But ultimately, people in the carnivore community have been going from a really high, sort of many of them vegan, plant-based diet, or a diet really high in oxalates, a Western diet, and they've been going immediately onto carnivore. And they see benefits. So clearly not everyone who has these issues needs to do this, gradually. Some people seem to be able to do it immediately. But for people who do experience symptoms related, or what they may think is related to oxalate dumping, there are certain nutrients which can really support that. So one of them is magnesium or potassium citrate. And this is because citrate actually has the ability to dissolve the calcium oxalate crystal. Okay, so it comes along, the citrate binds with the calcium, and then it renders the free oxalic acid, and you essentially dissolved it, and then that can be passed again through the urine. taking thiamine. This can help support, I'm not generally a massive advocate of supplements, but I know that temporarily in certain cases they can help greatly. So thiamine, the active form of vitamin B6, or eating lots of liver, I think that would probably help, and biotin. So these are generally the supplements or the nutrients which have kind of really helped to support people along if they feel that they are dumping. Okay, so yeah, basically I think that's everything. That's all of the slides. But just to round that up, I guess the main points is that many health foods that we're told are healthy actually are really high in oxalate. Oxalate can disrupt gut function. It can disrupt the gut bacteria. It can mess up with the cells, how they function, how they make energy. It can basically deposit in various tissue and actually cause mechanical stress. It can contribute toward inflammation. It can contribute toward chronic infection. Ultimately, it's a toxin. Your body can't do anything with it. And so yeah, it's something that I think we should be aware of. And I think it's probably one of the biggest problems in the keto diet, in the paleo diet, is that these things are extraordinarily high when they're not meant to be like that.